Hello, welcome to the Henstitute. Today we're going to talk about sound intensity. In other words, how loud the sound is, loudness. And loudness obviously is going to be related to the amplitude of the wave, but we talk about sound intensity in two ways. One of them is what we refer to as absolute intensity. And true absolute sound intensity is the amount of power that's coming out of the device. So if you look at a lot of devices, like say this speaker over here, and we look up on a speaker, a lot of times it'll give like how much power it is. So maybe this is a 20-watt speaker. And what that means is that when this is blasted up to full amount, it's kicking out 20 watts of sound power. And that vibration, we know we have this compression and then these rarefactions. So we get the little compressions together and then they spread out and then they get the compressed together again and then spread out. So basically how much we are actually compressing these things together or how much we're spreading them out, that's what we're dealing with. Now, as that sound travels out, we know the farther away you get from a sound, it's not going to be quite as loud. So I have two different people here. I have one person and number two. And the reason why is these lines are representing the power. And that was our full power. But as it travels out, it has to go through this little area. So these little area shapes that they've put on here, they're supposed to be little three-dimensional shapes, is the amount that's going through here. So our true equation for finding sound power or sound intensity, and it's usually designated with a capital I for the intensity of the sound, is actually the amount of power over a certain area or through a certain area. Now, if I talk about some object actually sending out sound in all directions, so this is maybe the source of the sound and it's sending it out in all directions, the area you might say is, well, isn't that just a circle? But then you have to realize that that's actually traveling in 3 dimensions. So we're actually talking about a sphere. So this area is often the area of a sphere, but it's actually the surface area of a sphere. Surface area. And so the equation often gets kind of changed. So we talk about power on the top, and then the ultimate area that it can travel over would be the surface area of a sphere. And the surface area of a sphere is 4 pi r squared, where r is going to be how far away you are from this actual source of the sound. So in this particular case, if I talk about person number 1 and person number 2 up here, person number 1 is this r distance away, so this would be r1, and then the second person is actually at a greater distance away, so this would be R2. And so what we find is if you increase the radius or you increase the distance away, you're going to actually decrease the sound intensity because you're farther away. So it makes perfect sense from that idea. Really what's happening from this picture you can kind of see is that the power has to spread over a larger area. So this sound intensity actually has a funny unit. It's actually in watts, which is our power unit, divided by square meters. So we talk about watts per square meter. And so if you have a very low power, you have a low loudness, it's not going to be enough to actually vibrate the eardrum, and you're basically not going to hear it. And the larger the area you spread it over, the more surface you're trying to travel that power through, and so it's going to actually get quieter. So that's a little bit on absolute sound intensity. I'm going to come back and do another little one on relative sound intensity. Hope you enjoyed this edition of the Henstitute.